Now let's look at another scenario. If you are given two angles and the included side of two triangles are equal, then is that information good enough to determine if those two triangles are congruent? Let's try to look at it. So here we have two triangles ABC and DEF, and we have been given BC is equal to EF and angle B is equal to angle E, angle C is equal to angle F, and we are saying that these two triangles will be congruent if this is the case. Actually, this is called a ASA theorem, angle side angle theorem, and it states that two triangles are congruent if two angles and the included side of one triangle are equal to the two angles and the included side of an other triangle. Because this is a theorem, we can prove it. So let's first think about how we will prove this theorem. So we know that from these two triangles there is one side BC which is equal to EF and two angles which are equal. Let's take the case where we have angle B equal to angle E and BC is equal to EF. If we prove that AB is equal to DE, then we will have two sides and an included angle which are equal, and hence by SAS axiom we can say those two triangles are congruent. So but we don't know if AB is equal to DE. What are the possible scenarios for a relationship between AB and DE? Either they can be equal to each other, or AB can be greater than DE in length, or AB can be less than DE in length. Let's try to look at all these three scenarios and determine if these two triangles are congruent. So that's the way we will approach to prove this theorem. So let's take the first scenario where AB is equal to DE. So we are making an assumption that these two are equal, and we have been given angle B equal to angle E and BC is equal to EF, and we have made an assumption AB is equal to DE. So by SAS axiom, which is if two sides and an included angle of two triangles are equal, then those two triangles are congruent. So we can say these two triangles are congruent. However, if AB is greater than DE, if that is the case, we will need to do some construction here. Let's take a point P on AB such that PB is equal to DE. Because AB is greater than DE, we can represent the length of DE on that line segment AB. So here we are making an assumption BP is equal to DE. So let's look at this scenario. Here we know that angle ABC is equal to angle DEF, and angle ACB is equal to angle DFE, and BC is equal to EF. These are all given, and we have made an assumption AB is greater than DE, and we have by construction drawn PB which is equal to DE, and based on SAS axiom, now we have PBC is congruent to DEF, because in these two triangles PBC and DEF, angle B is equal to angle E, that is given, and PB is equal to DE by construction, and we also have BC equal to EF which is also given. So by SAS axiom we have two triangles whose two sides and an included angle are equal. So these two triangles are congruent. So if two triangles are congruent, all the angles of those two triangles are also equal. So we can say angle PCB is equal to angle DFE, because they are corresponding angles of those two congruent triangles. But we have been given that angle DFE is equal to angle ACB in number 2. So angle PCB will be equal to angle ACB. How can that be possible? If you observe here, we are saying this angle is equal to this angle. That's not possible. It is possible only when P actually coincides with A. So what we are saying is if you move this line in such a way that it coincides with A, so point P coincides with A, then what we are essentially saying is P is equal to A. So that's the only case when this statement can be true. So if P coincides with A, then it means that PB is equal to AB, and we know that PB is equal to DE by construction. So AB is equal to DE, which means now we have proven that AB and DE are equal, BC and EF are given to be equal, and angle B is equal to angle E, that's also given. So they are congruent based on the SAS axiom. Now let's look at the third scenario where AB is less than DE. We'll try to approach this similarly. We'll take a point M on DE such that ME is equal to AB. because AB is less than DE, the length of AB should be a part of DE. So we have constructed ME such that ME is equal to AB. So now by SAS axiom, we have two triangles whose sides AB, ME and BC, EF and the included angle B and E are equal, so they are congruent. Because these two triangles are congruent, their angles should also be equal. So angle MFE should be equal to angle ACB. But we know that angle ACB is equal to angle DFE, which is given. So MFE should be equal to DFE. Again, that can only be possible only when M coincides with D. So if M coincides with D, then basically ME is equal to DE. And we have constructed ME such that ME is equal to AB. So it means that AB should be equal to DE. And if that is the case, we have two triangles where AB is equal to DE, BC is equal to EF, and angle B is equal to angle E. So those two triangles, ABC and DEF, will be congruent by SAS axiom. No matter what scenario you take, it will end up with AB is equal to DE. So what it means that if two angles and the included side of two triangles are equal, then the other two sides will be equal to each other. So those two triangles will be congruent. So this is the proof for the ASA theorem.